Hello, my name is Vega and I'm representing Physics Lab 1 Constant Velocity. Introduction. The purpose of this lab is to observe the differences between the observed displacement of an object moving at a constant velocity and the predicted displacement of the same object moving at the same velocity. For this lab, the observed displacement will be calculated through the tracker app and the predicted displacement will be calculated using code in GlowScript. For this lab, the model made of observed values will be done in the tracker app and the model name of the predicted value will be done in GlowScript. This lab should help demonstrate Newton's second law, which states that the net force equals the change in momentum over the change in time. Here's a brief overview of my result, which will be the result at the end of the lab, which shows the predicted values in red and the observed values in blue. The givens in this lab is that the constants is the object I use, which is the marker, and the system that the lab is taking place in is the marker earth and counter system, and the counter is the marker that the marker was rolled on. This is Newton's second law, which states that the net force acting on an object is the change in momentum over the change in time, and as you can see in the picture, I've derived that equation into the change in velocity formula, or the velocity update formula. And basically, you can see that if F net is 0, or if there's no external forces acting on the object in the system, then the velocity won't change and it will stay constant. Here's step 1 of which is recording the video of the marker rolling across the counter. I wasn't able to put the video, so this is just a picture of the video where the marker was rolling. Step 2 is to create the observational model using tracker. You can see in the picture that all those little red dots are where I track the marker and where I counted the x coordinate over time. You can see in the table on the bottom right, I have time, which shows time every 0.33 seconds, and you can see in the second column you have the x value in meters for each time frame. Here's a computation model that I created using GlowScript. The things that I had to edit were the ball mass, which I just left as 1 because it doesn't matter. And then the ball position, which I started at 0.012, which is found at the beginning on the bottom right. You can see in the table the x at time 000 was 0.012. And then the ball velocity, the initial ball velocity I took the change in displacement, or the change in position over the change in time between 0 seconds and 0.1 seconds. And then for t, I started at 0.00, so I captured the entire time frame. And then for delta t, I used 0.033 because as you can see in the bottom right in this table here, the difference between each time step is 0.033. And then the while t is less than 0.6, I wanted to make sure that I got to 0.6 seconds so I could include the whole or all the values. And then f net, the vector was 000 because there's no external forces acting on the object, and we know this because the velocity stayed constant throughout the entire video. And then finally, the ball velocity update formula, I just inserted that in. And then same with the ball position update formula, I just inserted that in. And on the right, you can see that the velocity on the bottom graph is constant, and on the top, the position update graph, it just constantly increasing. And then here's the data from each model. The red line shows the predicted data, or the GlowScript data, and the observed data. The blue line shows the observed data, which is from the tracker app. You can see how it kind of starts off evenly, but then as it kind of time increases, the observed position seems to be a little bit less than the predicted position. And the possible error for this is external forces like friction air resistance. This would slow down the markers that the observed position is less than the predicted position. Another possible error could just be human error. As you can see in the tracker video, I had to manually click all of the positions for the x value, and there could have been some error there. And then what if x and negative x are switched? None of the magnitudes would change and the results of the data would be unchanged. All the physics principles stay the same, but the velocity would appear to be in the negative direction instead of the positive, and the position would appear to be growing in the negative direction instead of the positive direction. This means, and this shows how, when there is a net force of 0, that the velocity of an object will remain unchanged. In this specific lab only, the normal force and gravity were acting on the object in the y direction. These forces, however, canceled out, and there was also no forces in the x direction, which means that the net force acting on the object is 0, which explains why the marker remained at a constant velocity.